Okay, let's go over our location planning and analysis. So location decisions. So these are long-term, difficult to reverse, and they have to be strategic choices that would significantly affect both our fixed and our variable costs. So the main objective is to maximize our benefits. Gain from the location. This could include access to resources or markets, or maybe it has low operating expenses. So, for example, if we want to build a new city, not a new city, if we want to build a new factory, we are deciding between Mexico City versus Chicago. We're going to lock in those land costs, which are going to be fixed, and then we have to factor in our labor and shipping costs, which are variable for many, many years to come. We can't just pick it up and move it somewhere else. So we have some key questions that might come with that. So managers have to face a strategic choice. Are we going to expand the current site, add a new facility, relocate entirely? And so that means we have to prioritize certain factors that are going to be distinguished between our dominant, such as maybe our labor cost, our proximity to raw materials, depending on what we're doing, and then secondary, such as quality of life or local taxes. So an example could be the manager saying, should we add a warehouse near our current one, or maybe move it somewhere that's going to be a bit cheaper? Again, our general procedures is four main steps. So alternatives are then developed, and you could, for example, move from a country to a different region or community and to our final site, and then we're going to follow that by evaluation and selection. So they're going to, for example, first choose a country, and then a region, and then a few communities, and then finally decide the specific piece of land for the site. I'm going to skip through a few of these because, again, it just kind of goes through some of our benefits and disadvantages that might come based on where you are deciding to go. Then we have, so these are our primary factors, and then we have location models. So we have our weighted method. This uses qualitative factors, the locational break-even method, which finds the lowest cost based on volume, and the center of gravity method, which minimizes transportation costs to multiple destinations. So a coffee chain, for example, would use the weighted factor rating so that they could choose a city, and then the center of gravity method would be used to place the distribution warehouse. As we continue on, we have the transportation model. This is a type of linear programming to minimize the total transportation costs across an entire network. It's mainly used to optimize the flow of goods from several manufacturing sources to several final destinations. So, for example, an automobile manufacturer would use the transportation model to decide which of its plants should supply which regional assembly center to achieve the lowest overall shipping cost. So now we move into going over some of those, such as the weighted approach. This is a qualitative evaluation method. Relevant factors, maybe like your quality of life or local taxes or something like that, are assigned a weight based on the importance. Each location is then going to be scored on each of those factors, and the weighted scores are added together to find a final composite score. We want the highest total score to be our winner, and it's also important to know that the weights assigned are going to add up to 1. So again, I won't do the entire example, but we can see right here that they add up to 1. These are our factors that we looked at that we found important. And then if we find our scores, it's just this, we're going to multiply these all throughout and see which one has a greater sum. Next, we have our locational break-even analysis. This is going to compare locations based on their fixed and variable costs relative to expected volume. This is normally going to be plotted on a crossover chart, and then we want the location with the lowest total cost. Obviously, we want to spend the least amount of money. If location A, for example, is going to have a lower fixed cost but a high variable cost, and location B is the opposite, the break-even point is going to determine which is cheaper for their projected sales volumes. It's just going to depend on how much they're projecting to sell. I believe this is, that's just an example, center of gravity method. So this method finds the optimal location for a single distribution point, for example, like a warehouse, and that's going to serve multiple existing destinations. It's going to minimize shipping cost or travel time because we're calculating the weighted X and Y coordinates based on the location of the markets and the volume that is being shipped to each one. For example, a retailer is going to plot its 10 existing store locations onto a grid. And we're going to use this formula to find the mathematically ideal spot so we can build our new distribution center. So some of these steps, it's just going to go through how you would end up finding that. Same for this next slide, I believe. Yeah, so those are just some examples. And then we have the transportation model. This is a linear programming model, and that's used to find the optimal shipping strategy from multiple sources. For example, a factory with capacity constraints to multiple destinations. And the objective is to always minimize the total shipping cost with these constraints. For example, a shipping company would use this to calculate exactly how many containers from warehouse 1 and 2 should be sent to customer A and B to meet all the demands, but at the lowest combined cost. So example, maybe these factories have different things coming from them, and that's why we're figuring out, or warehouses, sorry. And that's why we're figuring out how to get it to customer A and B at the lowest combined cost. And then these slides are just going to go over some of the inputs that might be needed, and I believe the rest are just examples and charts, and so I believe that is everything.